Okay, welcome back. Now today we're gonna talk about portfolios. So how to build a portfolio. I imagine that students of accounting and finance know better than me what is a portfolio. Better than me, no, because I build portfolios myself. But okay, so a portfolio is a form of investment in which you pack different securities. In our example, we'll pack together only stocks. The reason for doing it is to reduce the risk. We will see in the next lesson what is the risk. So instead of investing all the money in a single security, we'll pack some of them together and invest in this diversified asset. Okay, the portfolio can be equally weighted, okay, in which you invest the same amount of money in each stock, or just weighted, in which you invest an amount of money which depends on some predetermined weights. Okay, also there are several other aspects. A portfolio can be rebalanced because the prices will go up and down, and after some time some stocks will be worth more than others. So you should need to rebalance, but this is something we don't talk about. We'll just see how to calculate the return of a portfolio. Okay, as usual we have to import numpy as np. Numpy, I don't know whether we have already seen it, probably yes, means numerical Python. It's a package which contains numerical function. In particular, we need matrix calculation here today, so we will have to import numpy as usual, or favorite animal. Okay, here we go. Okay, we download 4 different, say, the usual companies, but not really the usual, but tickers. We download a PG. PG is Procter and Gamble. If I remember, it's a retail company, so pretty stable, traditional. This is Microsoft, Ford, and General Electric. So for different type of, and now d equal yf dot download. We download tickers starting from our usual start. Okay, and don't forget that we download only the just close price. Okay, takes a while. Then we take a look, always take a look, a preliminary look at least. Okay, everything seems fine. Okay, now first thing, we take a look at their graphs. Okay, if we just look at the graphs like this, okay, okay, you produce a graph like this and I will award you 0 point, or better than 0, negative points, because it means that you didn't understand anything of finance. Okay, a graph like this is totally meaningless because they don't start from the same amount of money. So here it seems that Ford is straight. Okay, well, okay, Microsoft goes up, but seems, for example, that General Electric has huge oscillation, but it's not true. You will see soon. In order to put them in the same graph, you have to normalize them. So they have to start from the same value. So how do we normalize them? Well, we normalize them dividing all these values by the starting value. So if I divide all the values by the starting value, I remind you that d I log of 0 is the starting value. I could also write d dot log of 1995-13, but d I log 0 is the same. You will see now here 1 and here 1 point something. Can you see? Okay, since we human people like to have a base 100 way of thinking, I multiply everything by 100. Okay, now this graph will be plotted. So I put a big parenthesis around, the spaces are only for aesthetical purposes. Plot, just to fig size equal 1020 is the usual size I use. Oh, not, no, it was 2010. Okay. Okay, here you can see that Microsoft is really killing all the others, but very killing. And you can see that General Electric doesn't obsolete at all, but really at all. It performs even worse than Procter & Gamble. Okay, can you see? Which is very different from the graphs that you have seen before. Okay, this is because all of them starts from 100. Unfortunately, it's not very easy to see, especially what happens here, because of Microsoft, which is killing all the others. So, unfortunately, Microsoft kills all the others, so we cannot even we cannot notice the differences here. But Procter & Gamble is going very well here. If we could exclude Microsoft, how can we exclude Microsoft? Unfortunately, it's the second. Let me try something bizarre. Let's try. It's something very bizarre. Colon, comma. Here I specify a list with 1, so 0, 2, 3. I hope it works, but I don't think. No, no, absolutely it doesn't work. Invalid syntax. Okay, well, there is a way to remove Microsoft, but I don't want now to do it. So we stick with Microsoft in the middle. There is also a way, if you search into the help on plot, there is a way to cut the picture here, or to use a logarithmic scale, or to cut the picture here. Let's see. Pandas plot logarithmic scale. The documentation for pandas plot. Ctrl F, logarithmic scale. We don't have the logarithmic scale. Here it is, log y equal true. So that's it. No, it's deprecated. Wow. Sorry, it's not deprecated, simply I used the capital Y. So this is how you can expand what we learn in class, even without... Okay, here you use a logarithmic scale, this is 100. Okay, so here you can see better, Microsoft is still growing up to 10 to the power of 4, it means that from 100 it goes to 10,000. Okay, and you can see much better the differences here. Okay. Another alternative would be to cut the graph, so not to display what happens at the top, so cut the graph, let's say at 2000, and for sure there is here, for example, ylim probably. It's here xlim, ylim. Let's see, I try, so you learn much better something new. Ylim equal 2000, let's see. No, okay, no, ylim equal 0, 2000, that's it. Okay, so this goes from 0 to 2000, y, so I cut it, and I can see that also General Procter & Gamble goes up 2500. Okay, so now here you can really see it better. Okay, so we have also learned some new things here to put. Okay, but this is the graph now. Okay, this is normalized. I have written it in the wrong place. Very well. Now we calculate the returns for the portfolio. No, for the portfolio, for the 4 stocks. Returns equal D. The method was D divided by D dot shift 1 minus 1. This is a possibility, or even better, PCT change 1. Okay, and this produces the returns. Let's take a look at them. call it returns, because if you call it return, it's a reserved keyword. So okay, the first one is missing. This is not something new. Okay, daily returns. Now finally we built a portfolio. In order to build a portfolio, we have to set up the weights. So which weight will have? Procter & Gamble will take a weight of 20%. Microsoft 35, and the next one is Ford 25, and General Electric 20. Okay, pay attention that the sum of weights must be exactly 1. Does it work? Something like that? I don't think. No, you have to write it like this. Okay, so pay attention that the sum must be exactly 1. So okay, that's it. Weights has been defined. And now, how do we calculate the portfolio return? The portfolio return is calculated in this way. Here I assume some returns. I'm not taking exactly these ones. I assume some returns. Let's suppose the first 4 returns are these ones. Okay, so you have to multiply this one by 0.20, this one by 0.35, this one by 0.25, this one by 0.20, calculate the sum and get the result. So this is the weighted average of the first 4 returns. So the weighted average of these 4 returns. Then again the weighted average of these 4 returns, this one by 0.20, plus this one by 0.35, plus this one by 0.25, plus this one by 0.20, and so on, line by line by line by line. Or doing this operation line by line, well, doing it manually, it's absolutely out of question. It's not something human people will do. Doing it automatically with a loop for the people who are able to write programs, it's not efficient. It's much more efficient using matrices. So if we look at the data frame is nothing else but a matrix. In here I depicted a 4x4, but the matrix is 4 columns and 608,035 rows. Okay, so we could take this matrix here and do a matrix multiplication of the matrix by the vector containing the weights. Here, unfortunately for you, I require that you have some, at least the very basic knowledge of matrices multiplications. Well, I'm sure the people who studied it at University of Bolzano had it, because I saw Professor Kaniowski doing it. The other one. So, what I'm doing here is exactly the standard matrix multiplication. If you multiply a matrix by a vector, you do exactly this one. So multiply this one by this one, plus this one by this one, plus this one by this one, plus this one by this one, and put the result here. This one by this one, plus this one by this one, etc, etc, etc. Okay, so in practice, what we must do, we must multiply the matrix containing all the data frame of the returns by a vector containing the weights. Okay, let's do it. Do we have a way to multiply matrix? Yes. NumPy has the function dot, literally dot, because the matrix is usually indicated with a little dot here, the multiplication, with a little dot here, which multiplies a matrix by another one, or a matrix by a vector. Okay, so portfolio returns equal NumPy dot the matrix, which is returns, it's a data frame, and the vector weights. Okay, usually several programming languages here would complain because you have an object which is not really a matrix but it's a data frame, and an object which is not really a matrix but is a list. Python is very tolerant, will understand that a data frame is practically a matrix, and a list, where is the list here, this one, is practically a vector. So we'll understand, and if they have the exact shapes, so the vector must be exactly of size 4, because the matrix has 4 columns, the vector must have exactly the same number of columns as the matrix. Okay, we'll perform it. Let's see. Portfolio returns. Okay, so let's see the result. First result, it's none. Well, not surprising because it's none, 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 none by some numbers makes none. Second result is 0.00554 blah blah. Let's see, is this thing here? Well, all of them are close to 0, so not surprisingly. Okay, so seems correct. Pay attention to the result. Technically, it's an array. Don't worry, it's exactly the same as a list. In fact, you can see Python uses the square bracket. For you, it's exactly the same as a list. From a technical point of view, it's very different, but for you, it's more or less the same as a list. You can do basically whatever you want with it. Okay, so we have all the returns. Okay, now let's calculate the average. Portfolio returns dot mean. None. Why none? Because one of them is none, so I remove the first one. So this means from the second one, because in Python 1 is the second one. Okay, so this is the average daily return of the portfolio. Now, if we want to get the yearly return, the annual return, I remind you that these are simple return and not log return. If this were a log return, it would be easier. Just multiply by 250, that's it. But unfortunately for you, these are simple return. So in order to get the annual return, I have to add 1, raise this to the power of 250, which are the average trading days in 1 year, and subtract 1. And this is 15%. Okay. So 15% is the average yearly return of my portfolio. So print the annual return. No, it's not the average, so it's the return. The annual return of my portfolio is comma. Now I cannot write it. If you write this something like this to a customer or to your boss, they say, what the hell is it? Okay, so you have to write in a human readable way. How do we do it? First of all, I multiply by 100. So let's write it into a annual return portfolio ARP. Okay, is ARP by 100. Let's see. Okay, then I add a percentage symbol. Okay, better. Then I have to cut all these digits after the comma. How do I do it? Well, round with 2 digits after the comma. Okay, very human readable. Okay, that's it. If you prefer, you can round it to 4 digits after the comma and then multiply by 100. Same thing. Okay, there is no way to remove this space here, because whenever you put a comma, the space is automatically inserted. Okay, so this is how to build portfolio and how to multiply a matrix by a vector in such a way to calculate automatically all the returns without having to build a loop which in sequence goes through all the elements one by one, does then another loop which does all the multiplication and all the sum, etc, etc. Everything is done with a single command, which is not only easier to write for us, but in particular this is also much more efficient because NumPy dot has been designed to be very efficient. Okay, indexes. You can do exactly the same with indexes. So let's take some indexes. Stickers equal. Indexes in Yahoo start with a little hat. GSPC. A good luck to people having a German keyboard. To produce the little hat, usually you have to type the hat and then space. I've never understood why it is on a German keyboard. Little hat, IXIC. Little hat, GDXY. Oh, which indexes are they? This is standard and poor 500. Okay, probably general, standard and poor 500. This is the Nasdaq, and this is the DAX. Oh. Okay, download a file in the yf download tickers start equal, where is it, 1995 bin 1 a adjusted close. Okay, and here equal, take some time. Okay, I noticed that we have some missing here and some missing here. This will create problems, this one in particular. Okay, let's produce the graph. I copy from above. Let's produce the graph to look at them. This one, the normalized graph. Instead of D now we have ind. I don't need to limit anything now. And in the graph you can see that the only one which appears is the DAX. Why? Well, because unfortunately the Standard & Poor and the Nasdaq were closed on the 2nd of January 1995, or we don't have any data. So it happens that when we try to make this division, if you make a division by something which is none, the result is none, all nuns. And with all nuns, in fact, if you don't plot but just, okay, all nuns, can you see here? And with all nuns, there is nothing to plot. Okay, so how do we solve it? Well, we could solve it, for example, doing the division with the first one, okay, or even better, just fixing it in this way. I produce ind2, which is ind1 dot iloc 1 colon. So I remove everything from, oops, sorry, it's ind. Okay, so now ind2. Okay, I removed the first datum, and now I can here plot ind2, and here 0. Okay, you can notice that despite there is not a number here, none means not a number, there is a missing datum here, the plot still works. Can you see here there is a little spot for that none, also here the little spot, the little white spot for that none, but the rest of the things are plotted. Also here there is another spot, can you see? Sometimes it's missing the information. Okay, let's comment this graph. We can see that the three indexes go together, except that the Nasdaq here overperforms the others. Well, it was the internet bubble 2000. And then after the internet bubble, the Nasdaq goes along with the others. Here the German index goes down for some years, but then during here there is the financial crisis of 2008, it catches back the other three, the other two, and they all go together. Only here the Standard & Poor starts to outperform, also to underperform. Also the DAX starts to underperform, and it's only from here that the Nasdaq it cannot be taken over again. So from here the Nasdaq does what Microsoft did in the previous graph, so up, 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 and not even the COVID crisis. This perhaps is the recent, I am recording this video during the beginning of the, or probably, hopefully the end, but it could be also the beginning of the Ukrainian crisis. Okay, so not even the COVID or the Ukrainian crisis is, the Nasdaq is dropping so much as to reach the other ones. And here we can see also that the Standard & Poor, starting from, let's say, more or less here, 2018, it's outperforming also the German index, outperforming a lot, because this distance is pretty a lot. Okay, now you can notice that here, in order to get rid of the missing value, I simply brutally just started from the next line. Okay, we have, however, other better, let's say, less brutal ways to get rid of the missing values. The first one is pretty brutal as well. Drop NA. If you apply drop NA, this thing here returns a data frame with all the rows in which there is at least one missing value removed. So if we apply it to here, this row will be removed because it contains, even this valid number will be removed because it contains at least one missing value. Okay. There are better ways. Fill NA will try to fill the missing values according to the method you specify. You can specify here a value, and in that case it will fill the missing values with that value fixed. Okay. You can specify here method equal ffill, and in that case this means forward fill will fill a missing value with a previous value. So previous values are forward pushed to fill missing values. Same thing for backward fill. Okay, it will fill a missing value with a next value. There is a limit, if an optional limit argument. If you specify it, it will not fill gaps which are larger than the limit. This is because if you have a gap of 3 years, well, it doesn't make sense to make a forward fill or a even worse, a backward fill. Okay. What is, however, often used is the interpolate. Interpolate will use linear interpolation if you choose as a method linear. Okay. So if a number is 3, then the next one is missing, the next one is 7, the interpolation says that the one in the middle will be 5. Okay. However, sometimes, as you can see here, exactly in this example, here look, 18 February, 21 February is the missing one, and 22nd February is the next good one. So here it doesn't make sense to use linear interpolation because the distance between this one and this one is 1 day, but the distance between this one and this one is 3 days. So you could use method equal time, which is a linear interpolation, but which takes into account the fact that there are some more days of difference here. Well, let's see. So ind2 equal ind. Okay, no, I don't even write. I just use the first of all drop NA brutal, and you can see that you don't see any NA anymore, and the 21 of February has been completely dropped. This is brutal. All this method don't modify ind. If you wish, you have to write it like this to modify ind. So they don't modify ind, don't worry. Fill NA with -1. Pretty strange, this applies in special cases, or with 0. For example, if these were volumes, you would like to fill the missing values with 0. Okay. Fill NA method equal. You can use single quotation or double quotation. In Python they are exactly the same. Fill. And you can see here that this one has been filled with the previous one. So the previous one has been pushed forward. This one has not been filled because there is no previous one. Backfill. Now this one has been filled with the next one, and also this one. And interpolate it. Interpolate method equal time. And you can see that the missing one here, this one has not been replaced because there is nothing on the other side. This one was the missing one. 4304, 4348. This is not the value in the middle. It's closer to this one because there is only 1 day here of difference, and here 3 days instead. Okay, goodbye. See you in the next video.